Hi, this is Frank Cohen. I'm the founder at Starling Watch and the principal maintainer of the Reflections open source project. And I'm going to tell you what kind of experiences that I've had lately at USB support on the ESP32-S3 and why it frustrates me and how hopefully some of the stuff that I learned will avoid the same frustration for you. My project delivers open source mobile experiences, and it's a combination of open source Arduino, ESP32, and it's a really great maker project, which means everything I'm going to show to you is available to you for free under open source agreements. You'll find the work at github.com/frankcohen/reflectionsos. And then I have a small company called Starling Watch where we build experiences built on top of the Reflections platform. And these can be a series of like pocket watches and wristwatches. Recently, I was on the Espressif forums, Arduino ESP32 section, and I posted this issue report. ESP32-S3 USB frustrates me, you too. And I got 41 comments. So yeah, I'd say that USB support on the ESP processor is a big issue and a stumbling block to the success of many projects. And let me tell you what my experience has been, kind of my path to getting here. Arduino really is a path. There is no kind of starting point for Arduino other than your own excitement and your own vision for what you want to create. And there's a ton of people out there that will help you and support you to make your vision into a reality. For me, I simply wanted to take the videos that I had taken of my kids when they were growing up and to put those videos onto a wristwatch that I would wear with pride. And so I decided to go the Arduino route because I knew that if I made this an open source project, then I could contribute back all of these engineering solutions I had to come up with back into the Arduino community, and that would make me feel better and about the world and really to contribute to everybody's success at making stuff. The ESP32 processor is really just a dream come true. I've been doing Arduino development for the last like 15 years, and I was even a speaker at the most recent 3 maker fairs when they were running to talk about what my Arduino experience has been like. With the ESP32, it came out about 5 years ago, and it supports Wi-Fi and Bluetooth, a couple of different buses that are really popular, so like I2C and the SPI bus. It has tons of pins, which for anybody working on, say, a robotics project, that's going to be great. And it has built-in USB support, which I just thought was great. The USB support for an ESP32 supports things like uploads and debugging, uploads of the software that you're writing for it, get uploaded into the ESP32 over USB. So it's very easy. And then the ESP32 USB support supports debugging. So you could run a debugger and be able to see on your laptop what's going on inside the ESP32 as it's running your software. And then, of course, the USB ports on these ESP32 development boards supply power. So you don't need like separate power supplies. The issue of the ESP32, though, is that it is kind of a moving target. There's a whole bunch of different versions of the ESP32 processor, and it can be frustrating to figure out which one is going to work the best for you and how to solve problems that you're going to encounter. My own project using the ESP32 is a combination of storytelling and mobility and animation in a wristwatch box or a package. There are 3 different major new technologies here. There's being able to develop modern experiences, not apps. So I'm not trying to replace the Apple iWatch, for example, or any of the Arduino Android watches. Those are great watches that have an operating system and they're app built, and so people are building apps for them. I'm not intending to do that. Instead, I want dedicated modern experiences for example, showing my kids videos, and I'm not interested in like creating kind of a general purpose platform for running apps. And so I've created the Reflections board, which is a very small 34 millimeter round board with an ESP32-S3 processor on it. And I've done all of the software and hardware integration with something I call Cloud City. It's basically an internet server that's going to provide the wristwatch with whatever it needs to be able to download those videos and actually play them. All of this is at the Reflections project, the Reflections repository. So just to compare, say, the Arduino boards that are out there to the Reflections board, the Arduino boards like the Arduino Uno, it's fine for blinking one LED. It has support of a software development environment called Arduino IDE, but you're doing just about everything in C, the C language. And I'll tell you, the C language in 2023 is about 40 years overdue from the C language itself just going away. C is a terrible language. It's awful for maintenance. It's awful for compatibility. It's awful to try and get libraries that other people have written working with your own code. There are solutions like Platform IO, which make it easier to write in C, and also Platform IO delivers a debugger that can be used to see what's going on within the Arduino board and the processor. But man, it's these Arduino boards have really very small memory footprints. We're typically talking about 2 to 4 megabytes of memory at most. So if you're trying to do anything with video or images, you run out of memory immediately. There's no networking support, there's no Wi-Fi, there's no Bluetooth, there's no operating system really. It's just saying, hey, what do you want me to do? And then you tell it to do something. There's no package manager, so there's no way to easily update the code that you've downloaded to the Arduino boards. There's no security or storage, there's no multitasking, and I'll tell you the real-time operating system, or RTOS, just isn't up to doing much of anything useful. And then you have to deal with like bootloaders that actually receive the uploaded firmware code, and those bootloaders are all over the map in terms of what they do and how you learn how to use them. Reflections on the other side is great for building experiences. It comes with a 34 millimeter round board, so that's small enough to fit into, say, a woman's wristwatch. It uses the ESP32-S3, and it is compatible with the S3 DevKit M-1, meaning that even before you did anything with the Reflections board, you could do something using an ESP32 dev kit, which is you can purchase those from Adafruit or even Amazon, or any of the other suppliers out there. It works with Arduino IDE 2.1, which means that you get a debugger. So you don't need to learn like the Platform IO environment, which is going to be completely different than pretty much anything you've done before. You have a choice of either programming in the C language or, thanks to Adafruit, in Python. There's MicroPython, or I forget the other name. You still have to deal with terrible C libraries and the awful C language. But at this point, I'm like wondering, what's the need for Platform IO if you've got Arduino IDE 2.1 with the debugger? Okay, there's still no package manager, OS, or apps, or security, but there is cooperative multitasking, and you don't have to worry about the bootloader at all, because Espressif, the maker of ESP32, has created one for you. Okay, so you might think like, oh, this is great. I'll just get started using the ESP32. Well, the problem there is that there are actually 4 different ways of using USB support on an ESP32. And only one of them really, I think, is useful. And when I say useful, I'm saying that I have 30 years of software development experience under my belt. And of those 4 ways of using USB, they're all like have terrible pitfalls and they don't work sometimes. There's only really one useful way of using USB support with the ESP32. And that is using the combination of USBCDC, JTAG, Open OCD. Now, I'm not going to cover what these things are because I'll tell you as a software engineer, it just doesn't matter to me. These are the protocols that make Arduino IDE 2.1 and its integrated debugger communicate to the ESP32 processor to be able to upload new firmware, new code, and then to be able to debug that code as the code runs. To use this one useful way, you'll have to do what I did, which is to build a custom cable. And that's going to connect from a USB port on your laptop to the pins on the ESP32-S3. And so that's what I've defined here. You have to connect to 4 different pins: GPIO 19, 20, the +5 or VDC, and ground. And then within Arduino IDE, you have to set certain settings, and so that's why I included this list of the settings so that you could use them yourselves without having to fumble around as I did. Now, if you want to know what all 4 ways of USB support there are, what I'd recommend is you take a look at Andreas Spice's video, and that's the video that I listed here. Andreas is my go-to expert at everything Arduino and everything ESP32, and he literally has hundreds of videos on YouTube that explain in very good detail the issues that you might bump into using Arduino technology and how to work around them. And so I'd say Grüezi Andreas if he's listening or watching this, and danke vielmals thank you for your contribution to Arduino community success. So what do you get by adopting that USB cable and then the USB settings within Arduino IDE 2.1 is really quick uploads and great debugging support. So you can set breakpoints and you can explore or examine what variables are as the breakpoints are hit. And that makes the software development process go that much faster. The rest of this video, I'm going to cover some of the kind of nitty-gritty stuff that I've encountered, and hopefully this will be useful as a list for you to keep in mind so that you don't have to spend or waste your own time as I did. So this is the downside of ESP32-S3. First of all, there's a whole bunch of different ESP32s out there. They started with just the ESP32, then they added the ESP and an ESP32 that only has 1 core. I think that's the ESP-S1, which maybe not even got to market. The S2 has 1 core and limitations around Bluetooth. So for example, only the original ESP32 supported Bluetooth Classic. So if you're using an ESP32, it comes with BLE or Bluetooth, Light Edition, BLE support. And so BLE version 5 will support extended protocols like the A2DP audio protocol. That would let you over Bluetooth stream, say, a music, an audio file to a Bluetooth speaker, wirelessly. Well, the S3 only supports BLE, not Bluetooth Classic, and so there isn't any support for A2DP audio, that protocol for streaming audio. The BLE working group, or the Bluetooth working group, has come out with a version 5 spec, which greatly moves BLE up to being on par with what Bluetooth Classic does. But Espressif, the company that makes the ESP32, has yet to say even when they're going to support Bluetooth or BLE version 5. There is a confusing and endless list of how-to documents out there, and many of them lead to nowhere. There's no kind of start here when working with ESP32 technology. Even Espressif will show you that there's support for the Arduino IDE software development environment, and yet Espressif has their own Espressif IDF, I think it's IDF, as software for doing software development on the ESP32 boards. So just don't expect any start here. You're going to be kind of wandering around for a while, figuring out how this stuff works together. The board definitions that you get within these software development environments all expose and hide different controls. So for example, when I showed the list of settings for my solution of building that cable and using CDCJTAG and OpenOCD, there's a bunch of different settings that will appear or not appear depending on which board you select. That's pretty confusing. So let me just cover again. The USB itself on ESP platforms is confusing and frustrating. If you see the 4 different ways of using USB, they include things titled TinyUSB, OTG USB, CDC plus JTAG, or JTAG debugging boards. The only one of these that's useful at this date is with the ESP32-S3 would be CDC plus JTAG. Only use CDC, JTAG, and OpenOCD with this custom cable that I've recommended. And the reason for that is that there's been kind of a journey that Espressif has been on in supporting USB within their boards for a long time. So for example, the USB support that's in the S3, if you were to plug in a USB cable, like a stock cable, not like the cable that I've just shown you here, if you're just to plug in a stock USB cable between your laptop and an ESP32 development board and upload some firmware, there's no way to have that upload automatically restart the processor to automatically run the code. So you have to click the boot button and the reset buttons that are provided on those development boards, and you have to click them in a certain order and at a certain speed. And if you don't, then the ESP32 just says, what do you want from me? And that's because the firmware update can't restart the processor by doing a firmware update. You have to press those buttons. The other thing is that these ESP boards, they come with flash storage memory. So like the ESP32-S3 comes with a 32 megabyte flash storage built in. And the cool thing is that they support Espressif, or the ESP32 supports MSC, which is the mass storage control, which makes the ESP32 over a USB cable look like it's a hard drive that you're attaching to your laptop. And then once the hard drive appears on your desktop, it's very easy to then just drag and drop files from your laptop into the ESP32's flash memory. The only downside to that is we're talking about 32 megabytes here. So, even a single image from, say, a megapixel camera is going to fill up that 32 megabyte storage. So what I've done in the Reflections project is to add on to the Reflections board a multi-gigabyte SD card. It comes in a package called NAND, and it acts like another flash storage device that's attached directly to the ESP32 processor. So you talk to it as though it's an SD card or another volume, and you're able to access all of the gigabytes of storage that are there. And so in the Reflections project, I have an MSC driver that makes that attached SD card through NAND appear as a volume on your laptop, and it becomes very easy for you then to drag and drop really big video files onto the board's SD card. So at this point, I would treat anything titled ESP32, S2, or C3 as legacy, and I'd recommend you only use the ESP32-S3 or whatever comes next for the S3. And that's because the S3 has all of those different protocols like Wi-Fi and Bluetooth or BLE. Plus, it has dual cores. It has a lot of memory compared to the other ones. And it's got a great price. Last two things on here. I find that the forum support from Espressif and from the Arduino communities is just excellent. However, I do find that oftentimes the left hand doesn't know what the right's doing. So sometimes the Arduino community answers won't match up to what the Espressif forums are doing for the ESP32. The really cool thing is that Espressif just seems to be just on top of their game at doing the hard work to make the ESP32 compatible with the Arduino IDE and the Arduino kind of code library base. So that's really good. Okay, so do you want to play? Please take a look at the Reflections project. It has everything that you'd want, the Gerber files for the Reflections board, all of the software that we've developed, all of the utilities, all of the experiments. And then take a look at starlingwatch.com. Later on this year, we'll have an announcement for an experience that will let you see and interact with characters that might live on your arm in a wristwatch. I'm not going to say anything more than that, but this starlingwatch.com would be your source for that. I hope this has been useful for you, and thank you for your kind attention. Please let me know in the comments what you think about this, where I got this right and wrong, and you know where I should be spending my attention to educate myself even better. Thanks a lot, and I hope you have a good day.